Lesson 3, we're going to be connecting radian measure and trigonometric functions. This hopefully will be a really good lesson that starts to pull together some of the information we learned in the last unit and the information that we've learned so far in this unit. The horizontal axis. So if we're looking at a periodic function, and we are really going to focus on the sine function, mostly just because the curriculum does state for this course that we would focus mostly on the sine function. So just as an example down below, we have a horizontal axis. So the horizontal axis would be the axis that sort of cuts this function in half vertically. The amplitude is the height from the mean or rest value of the function. If this function, let's say the maximum point was +2, and the horizontal axis was the x-axis, and this point over here is at -2, this amplitude would be 2. So we don't count it as the highest point to the lowest point. The amplitude is just from the maximum point to the horizontal axis. As well, there's something called a period, and the period is the distance required for the function to complete one full cycle. So, for example, going from this point here to this point here isn't one period because we're really only halfway at this point. When we reach the horizontal axis again, the function is still going down. So it's only when we get back to here that we would have gone, this would be one period. The two most commonly used measures for angles are degrees and radians. So we have talked about both in the last couple of lessons. There are 360 degrees in a full circle and 2 pi radians in a full circle. Why sometimes, instead of having degrees along our x-axis, why we sometimes prefer to have radians is because we can kind of omit the radian symbol, and radians can represent a length, so we're able just to have an x-axis. When we graph a trigonometric function, the horizontal axis now represents real numbers in the exact same way as it does when we graph other functions. In lesson 1, we graphed the function y equals sine theta using degrees. Recall, so from lesson 2, 1 degree is the same as pi over 180 radians. We're going to look at the unit circle, and I love this unit circle because I think it really starts to help us understand how all of these exact values and how everything is tied together. So when we look at this unit circle, imagine that the radius is 1. So if the radius is 1, that means that the radius up here is also 1, and all of these lines drawn around the circle would all have a radius of 1. A few things we could do to fill this in. Imagine this point then would be 1, 0. And up here we would have 0, 1 and -1, 0. And down below we would have 0, -1. I can also fill in some of my angles. So the way that this is divided up, you know that this is 90 degrees, and this over here is 180 degrees. We know this is 270, and if we came all the way back around, we'd be at 360 degrees. So how is this divided up? Well, the very first angle here would be 30 degrees, and then half of the 90, so this would be 45, and this would be 60. When we look at 30 degrees, if we imagine this as our angle theta, if I was going to draw a vertical line straight down, and it was 90 degrees, it doesn't hit this point over here, it just comes straight down. So the idea is, okay, what are these values? So 1 was the measurement that went right from the center to the outside. So if I remove that, what I want to know now is, how far is it just from the center just to this point here? So we did have this chart that we used in our last unit, and it is showing exact values for different angles. So sine theta of 30 degrees is 1/2. If we're talking about the unit circle, we know the radius is 1. So if the opposite is 1/2, we can also see that the cosine of 30 degrees is √3/2. √3/2 would be our adjacent down here. So if I was looking to find out what this ordered pair is right here, I would have the x-axis going sideways as our point. To find this point here, I go √3/2 and then up 1/2. If I look at 45 degrees, and I imagine drawing a line down here again, I'm not going to do this for every single one, but if I imagine drawing a line down for 45 degrees, my sine is root 2 over 2, and my cosine of 45 is root 2 over 2. So what also makes sense is that we're looking at cos theta and then the sine theta. So we can go all the way around the circle, which I'll do. If I look at 45, I'm doing cos and sine of 45. So when I look at 45, root 2 over 2, root 2 over 2, but try and remember cos is first and sine is second. If I'm looking at 60 degrees, cos is first, so I go 1/2 and root 3 over 2. So this point here would be 1/2 and then root 3 over 2. And these are all positive as we go. So what's going to happen when I come over here? If I'm looking at 120 degrees, let's say, it's going to be very similar to what I had up here on the opposite side, except now my x value is negative. So in this quadrant, I'm going to have a negative x and a positive y. In this quadrant, I would have a negative x and a negative y. And over here, I'm going to have a positive x and a negative y. So the points just get repeated where they are in what position. So here I have negative 1/2 and root 3 over 2. The last thing that we'll look at that's really interesting is imagine how many radians we have. So we know over here if this is 0, we know going 180 degrees, that would be pi. And if I come all the way back, we've been talking about a full rotation would be 2 pi. So it might make sense that up here you'd have pi over 2. If this was just divided into 2 sections, you could see that if I ended up being down here, it would be 1.5 sections. So down here I could have 3 pi over 2. And this would be in radians. So then we can look at, let's say, 30 degrees. Everything's going to be in lowest terms as we go. So imagine this pi, 180 degrees pi. Imagine that being divided up into just 30, 60, 90, 120, 150 into 6 sections. So here we would actually have pi over 6. When we look at 45 degrees, let's say we've just divided it into 45, 90, 135, and we divide it into 4. So this 45 degrees would be pi over 4. When we look at 60 degrees, let's go back to this pi over 6. So 1, 2 out of 6. If we had 2 out of 6, that's the same as 1 out of 3. So this is pi over 3. So it's always in lowest terms. Over here, again, let's say it's out of 6. We have 1, 2, 3, 4 out of 6. But instead, we'd write that as 2 pi over 3, just because of the lowest terms. Divide them up into 4 again, this would be 3/4 of the way across. So this is 3 pi over 4. And here, if they're divided up into 6 again, 1, 2, 3, 4, 5. This would be 5 pi over 6. Can't really reduce that one. When we look down here at 210, we're dividing up into 6s again because this is 30, 60, 90, 120, 150, 180, 210. So that would actually be 7 pi out of 6. When we get to here, we imagine we're dividing up into 4s, into quarters. So 45, 90, 135, 180. This would be 5 pi over 4. 240 degrees. Dividing it up into 6s again, so this would be 8 pi over 6 or 4 pi over 3. We have 3 pi over 2. When we get to here, we have 300 degrees. We're divided up into 6s again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 6. So we usually wouldn't leave it as 10 over 6. This would be 5 pi over 3. This one, we're divided up into quarters again, so we have 7 pi over 4. And here, if we divide it into 6s again, we'd have 11 of those, 11 pi over 6. So these are our radian measurements around the center there. So if someone asks you for the radian measure, the exact value of 60 degrees, it's pi over 3. So this unit circle, I'll attach a really nice one, but this is going to be so useful to answer questions. So for simplicity, we can look at 5 main points of the sine function. We're going to get into more graphing in our next few lessons, and I think you're going to like it because it's not that hard. Some key points. We had a lot more points in our first lesson, but in radians, if I look at 0 degrees is 0 radians, and sine of 0 degrees is just 0. If I'm looking at the sine of 90, so like the sine of 90, I can go back here. Sine of 90, if I'm looking for radians, it's pi over 2. And the sine of 90 degrees was 1. And another reason it's 1, the sine, it goes cosine, the sine is 1. So this actually helps remembering. This is really important. It goes cos theta and then sine theta. So these are the main points I want you to focus on from now on. We're going to have to get really good at graphing the sine function, and that is the one that we're going to focus on. So the sine function, these are divided up into radians. I want you to know that this is also 30, 60, 90 degrees, right? It goes the same way, and we're going up by 30 degrees each time. So this would be 180, and one rotation all the way back around is 360. If you're looking for 45 degrees, be careful there, that would be in the middle. This would be 45. Okay, so 30, 60, 90. If we're going to graph the sine function, you need to know, and I'll start to remember that the sine function starts at 0, 0. We have enough space here to space this out. We hit positive 1 at 90 degrees. We go back to 0. We hit negative 1 at 270 degrees, or 3 pi over 2, and then we come back up to 0. That is one full period of this periodic function. And this would continue on in both directions, so we have little arrows at the end, and this is just from 0 up to 2 pi. Another thing is that we could be graphing on the negative side as well, but again, the curriculum just sort of suggests that you're able to graph basically between 0 and 360 degrees. So our horizontal axis, our equation of a horizontal axis, this time it's right at 0, so it's y equals 0. The amplitude, how high up from the horizontal axis is the maximum point, or how far down. So our amplitude is 1, and our period is 2 pi. That's for one full cycle, or you could also write 360 degrees. Just a few last questions now. Basically, we were doing this before in our last lesson. We were doing putting our calculator in radians, but what if we want an exact answer for these values? So exact answers for cos pi over 3. What I'd suggest is you use the unit circle, cos of pi over 3. So if I go back here, it goes cos and then sine, pi over 3, that's 60 degrees, that's 1/2. The sine of 2 pi over 3. Sine is the second value in the ordered pair. 2 pi over 3 is 120 degrees, so root 3 over 2. And sine of 5 pi over 4, that is the second value in the ordered pair. 5 pi over 4 is down here, 225 degrees. Sine negative root 2 over 2 is the answer. And then the last one, cosine of 7 pi over 4. Cosine is the first value, 7 pi over 4 is over here. So root 2 over 2 is the answer for the last one.